and welcome back to my channel. On today's video we'll be learning displacement diagram. Okay, and please endeavor to subscribe to my channel and give the video a thumbs up. So we'll be considering this question. Let's dive in properly. Now from the question, let's start our parameters. So given that the out stroke was 70 degrees, the return stroke was 130 degrees, the dwell was 40 degrees, and then the remaining motion was 130 degrees. Now I'm using this formula. 20 degrees equals to 1 millimeter is like my constant formula. Okay, so if 20 degrees equals to 22 degrees equals to 1 millimeter, then 70 degrees will be equals to x, because multiply, you have 2 x equals to 70 divided by 2, you have 35 millimeter. So 70 degrees equals to 35 millimeter. I'm trying to convert every degrees to millimeters. So if you check it, it's just like doing the half of the degrees. Okay, so if just get half of 130, that's 65, dwell 20, remaining parts 60. Now the total angle in the circle is 360, so we'll also convert for 360, which will give us 180 millimeter. So after doing that, I will draw a straight line with 180 millimeter, that is 18 cm. I'll measure my out stroke first. Remember, it's out stroke first, that's 35, mark 35. There is out stroke, dwell, return stroke. Dwell is 20, so I'll mark 20 in that point. And then return stroke is 65, so I'll mark 65. And then the remaining part is 60 millimeter, then I'll mark 60. We've just converted our degrees to distance for millimeters. Okay, now we're given that the follower length is 40 millimeter. So I place my t-square at the beginning of the line and measure and draw a straight line there, a perpendicular line. Now mark out 40, and then 40 millimeter. Then I'll go half 20. I'm actually going the half for a reason. Sorry. After going the half, I'll divide my 40 by 6 because I'm dividing my follower by 6. That's to give me about 6.7, approximately 7. So I'll go 0.7, 0.7, 0.7. Okay. So that my center point is my third point. And I'll do it till I'm done with this. I'll number it 0, 1, 2, 3, 4, 5, 6. After I've done that, I'll get my t-square, my ruler, and I'll bring it up to the top, which is 6, and draw a straight line. Alright, this is where my drawing will stop. I'll bring it down to the baseline with the help of my set square. At this point I drew, I will draw a perpendicular line to touch that line 6. Okay, a line for every point. If you're watching the video to this time, please endeavor to subscribe to my channel and like this video, because of course it's helpful. That's why you're still watching. Alright, having done that, I will draw a straight line from all those points I marked on my follower. That is 0.5, 0.4, 0.3, 0.2, 0.1. I'll draw a very straight line. Please, if you have any questions regards how fast the video is, you can let me know in the comment section of the video. Maybe I could try slowing it down the next time. Alright, so having done that, I will have to, this is my out stroke, my dwell here, my return stroke, and then remaining parts. So I'm dividing each motion by 6. I'm dividing my out stroke by 6, return stroke by 6, my dwell and remaining parts are not motion, so I will not divide them. So after 35 divided by 6, I will have about 5.8. So I will just use like 6, approximately 6. I'll go 0.6, 0.6, 0.6, and then I'll divide it for 135 parts. Okay, so I'll do 65 divided by 6. I'll get that's 10.8. That's approximately 11. So I'll divide this return stroke side with 1.1 as 11. Remember, we did the out stroke with 0.6, so return stroke now we're using 1.1. So my always say always half it first, so that you can just put 2, so that you know you have even distribution. Alright, having done that, I'll put my mark ruler on this line. At all those points that I marked, I will draw a perpendicular line on every one of them. Please take note. By right, you are to draw the displacement diagram before drawing the main cam profile. But as my method is, I'll always show you guys a shortcut on how you can maneuver this displacement diagram and go straight to the cam profile even without drawing this. But if you want to impress the lecturer, just please draw the displacement diagram. Okay. Alright. Now the cam profile to this video, I will leave it on the description part of this video. You can watch and learn. Okay. Yeah, the real cam profile is, I'll give you the description part of the video. So after numbering, I'll go where 1 and 1 meet. I mark point 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. I'm just directly going vertically opposite. Can you see what I did exactly? So once I'm done, I'm joining with a very straight line. Now a straight line because it is uniform velocity. If I'm using, if it's just simple harmonic motion, I'll actually use a curve, a French curve. But this is UV for both outstroke and return stroke. I'm using straight line. So guys, this is it for displacement diagram. Thank you guys for watching and see you guys in our next episode. Cheers out.